So we discussed how the atherosclerotic plaque actually forms and how it deposits onto the subendothelium. And initially, because it is something that damages the endothelium, of course, the inflammatory process will kick in. And then we discussed this lesion progression, how initially the cholesterol depositing forms a fatty streak, which is nothing but kind of this pale yellowish kind of faded looking appearance. And then after, you have kind of some of the fibrosis kicking in to form the fibrous cap of the cholesterol plaque. Then you have the plaque, and then after you have this roughened or ulcerative plaque. And actually, this can cause the formation of something called a complicated plaque. So a complicated plaque is that once this cholesterol, this strange kind of accumulation due to the high lipid diet is accumulating, and once it deposits onto the subendothelium and it starts to undergo these kind of progressive lesion progression. Initially, it's just a fatty streak, and then it becomes raised and it becomes a plaque. It can form a complicated plaque. And what exactly is a complicated plaque? Well, a complicated plaque is something that is, once the initial atherosclerotic plaque ruptures, okay, and if it ruptures, then what does that mean? Well, the contents of the plaque will be deposited, will be kind of left into the bloodstream. Contents of plaque are also dispersed, and if it does not rupture, it can become eroded. So any kind of complication that occurs to this plaque is known as a complicated plaque. And it can if the plaque ruptures and contents enter the bloodstream, it can even form an embolus. Now, we are familiar with a thrombus, which is something that kind of forms a blood clot. An embolus is something that which then dislodges and then moves throughout kind of the bloodstream and goes to elsewhere. Now, let's talk about the gross appearance. Well, there is cholesterol depositing, and what we didn't manage to finish is that looking at the anatomy of the aorta itself, the blood vessel, you have your tunica insima, which is closest to the lumen of the blood vessel. Then you have your tunica media, which we discussed in the last part, is how it does contain all of these elastic laminae. And then beneath that, and smooth muscle, and beneath that you would find your adventitia. Now, the anatomy of the atherosclerotic plaque is that you have a necrotic core here. And it's, why is it a necrotic core? Because the further away you're getting from the lumen, this is not really getting that kind of, it's not alive. This is dead, kind of, it's a necrotic core because it's the core of the atherosclerotic plaque. And why does it appear characteristically white? That's because the formalin, in the process of actually preparing the H&E slide, the formalin and the alcohol kind of washes away the fat. And that's typical for anything, and that's what leaves these cholesterol clefts. Atherosclerotic plaque is fatty deposition. It's really cholesterol. Now, if I told you that the formalin or the alcohol washes away the fat, that's what leaves in its place these kind of whitish vacuoles, and this is known as optically empty inclusions. So these are these white-looking vacuoles that are left over after the preparation, and these can be called cholesterol clefts. Here are your cholesterol clefts, and these are important for histopathological identification. Now, that's why you can see these whitish areas within the actual necrotic core, and then above that you can see the fibrous cap, and in the last part I discussed how this fibrous cap forms. And then we discussed the tunicas, intima, media, and adventitia, and how there's a lot of thickening of the intimal cell proliferation. And then you have your lesion progression, which is your fatty streak, your plaque, and your complicated plaque. Now, about the gross appearance, well, you're going to have what are you going to have? Well, you have thickening because you have cholesterol deposition. So you're going to have a thickened appearance. Then you're going to have these, this is on the gross appearance of the aorta. What's the gross appearance? Well, it's going to be thickened. And then you have, what color can it actually be? Well, because there's a cholesterol deposition, it can look like a pale or yellowish kind of appearance. And then it also has something characteristic known as cracked protrusions. Cracked protrusions. And these are due to the atherosclerotic plaque. Okay, being kind of ruptured, kind of being eroded. Okay, and one more thing, you need to be able to identify your pink amorphous necrotic core, and you have these foam cells that are also coming in. Now, I told you about your histology. I told you about your empty lipid vacuoles, and those can be your optically empty vacuoles. And you can also find cholesterol crystals. And the other things that you can find are these macrophages. So in the whole process of when this atherosclerotic plaque is forming, you have kind of like these, this is the thickening, and you also have this these monocytes. These monocytes that come in, and part of the whole inflammatory process, these come in and these become macrophages. Whenever macrophages engulf lipid or engulf fat, these become known as lipophages. Okay, you have monocytes. These are the mothers and fathers of macrophages. They turn into macrophages as soon as these enter the bloodstream. Once these macrophages enter the bloodstream, if they engulf lipids or fats, they become lipophages. Their names are also foam cells. Now, complications of these include hemorrhage. It also includes aneurysm, hemorrhage, aneurysm. As you can see, my handwriting is getting progressively worse. Hemorrhage, aneurysm, and I have a list. Okay, and then you can have, oh yeah, all those characteristics of a complicated plaque: rupture, ulceration, erosion, and you can get downstream thrombosis. And don't forget aneurysm, because the entire intimate media are kind of thickening and weakening as a result.